Okay. I guess we'll angle it down to the rocket first. We've had to do this in someone's flat because part of the uni's closed today. It shouldn't have been closed, but it is. So apologies
Uh-oh.
for that inconvenience.
Uh,
Tom's got a
no
look.
worries. We will adapt and overcome.
You see from the sort of phone camera as well that we've got set up here.
I'll keep this on. Yeah. Can we do the mic on the camera phone then? So it stays on that?
Probably, yeah.
I mean, okay, I'll mute this one if you pop that on your phone then, Tom.
Right, can you hear us through the phone now?
Yes.
Can you...
There we go.
Right. Should we just sort of start at the nose cone and work our way down?
Yeah, you can just go ahead and start at the nose, work to the tail. And Chris, please feel free to jump in with questions or observations as we go here. Is be more of a discussion than just a strict presentation. Okay, so go
Yes,
ahead,
sir.
press on.
I guess start off by just we're still waiting on two components being machined, so you're able to see we've not got a nose cone tip over there. But that's going to be ready on Wednesday. So we don't have the M8 rod that runs through because usually we will compress it with an M8 rod running through to the bottom bulkhead, but we don't have that. And we don't also have the retaining ring for our avionics bay, but they're both going to be made this week. And yeah, they're
Okay.
documented in our tech report. But aside from
Yeah,
that,
so you're having those machined by someone else then?
yeah, we're getting them machined by our university, but they'll be ready this week. There's just a little delay on some of them.
Okay.
If you want to slide nose panel.
Yeah. So the nose cone we've got here is a 5:1 von Karman, which has been 3D printed out of onyx, which is nylon with chopped carbon fiber filament suspended in it. And we've then skinned it with a couple of layers of carbon fiber to give it and some heat-proof epoxy to help it survive the supersonic heating that might be acting upon it. So the sort of nose cone tip here, there'll be a threaded rod running down the length of the nose cone with the bulkhead to sort of hold it secure. The tip we made of aluminium, it's 125 mil long, and so that'll act as a heat sink to hopefully sort of stop any sort of overheating of the nose cone itself.
No,
Are you guys expecting to go real fast?
We're looking at sort of Mach 1.7.
Yeah, but this is our first time going supersonic, so we're being slightly overcautious on the heating aspect of it. The Onyx should have actually survived, but the carbon fiber improves the rigidity, and then those contact obviously heat sink as well as our attachment for recovery.
Yeah.
I think we were quite cautious on that aspect.
It should be fun.
Yeah.
Where are you going to put your tracking?
The tracking's in our avionics bay. That's mounted in the upper airframe.
Wait.
We can take that apart and show you in a wee bit.
I'm just curious, what is the airframe made out of?
It is 2 mil of phenolic that we've wrapped with 1 mil of fiberglass. So that gives us the structural rigidity on the outside with a nice finish on the inside. Because last year we made it ourselves and we degraded our mandrels. This time we're just using our mandrel and flying it as the phenolic. It just gives it a nicer internal finish.
Yeah, I was questioning more of where are you putting the tracker from an RF transparency perspective?
Yeah.
Yeah, that's in the upper airframe, but halfway down in between the parachute bays. So the phenolic and the fiberglass is pairing with radio waves, so that shouldn't be a problem.
Okay. Where are your separation points? What are you doing for parachutes? Traditional, you doing
So we're doing
single end?
dual deploy. So in here is our avionics bay with charges on either end. The drogue will come out at a separation point just down here, that you can see there, and the main will come out the nose up here.
Okay.
What are you
How
using to, yeah,
go
how
ahead.
is the, what, how big is the, excuse me, shoulder on your nose cone where it fits into there? And how many shear pins, what kind of shear pins are you using for that?
Well, if you want to, sure.
It's M3 nylon shear pins, which is the equivalent of 440s.
Okay.
And it's
I think he and I were concerned about the same thing. Like, what's the length of the coupler, the engagement?
on the
Can you
nose
pull the
cone.
nose
Can you
cone
just,
out?
can you
Yeah.
pull the nose cone out so
Yeah.
we can just see?
All right. So enjoy grab that. So it's a 1 cal, so it's 5 inches the shoulder for the nose cone, which is just coming apart now.
There we go.
So there would be a
Okay.
bulkhead on there as well.
Yeah, we're gonna put that.
And then our coupler down here is 8 inches on this side, and it'll be held by shear pins, and it's 5 inches down here, and it'll be bolted into the sort of payload support structure we've got. And it's an aluminium coupler, so we're tapping the holes for that.
Yeah, so the engagement on this side's 1.6 cal, and this one's bolted.
Okay.
But the nose cone's 1 cal, but it's quite a light nose cone, and it's also the fit on it. It's quite
Is
hard
it going to
to
be yeah, your nose cone is going to be empty effectively, right?
correct.
Yes.
Yeah.
Yeah. Okay. I'm good with that.
Okay, go ahead. Keep on going. Let's see. How I see where you've got your shock cord. So your second attachment point is going to be down inside. What's your shock cord made out of?
It's a Kevlar shock cord, so the drogue is a 5mm Kevlar, which is 50 feet long, and the main is again 50 feet of 8mm Kevlar cord.
Okay, and can you kind of show us? Point the camera into there. I know it's going to be dark, but kind of show us how you got it fastened in.
We can take the avionics bit actually.
Yeah.
Just to see.
Oh, is it attached to the avionics bay?
Yeah, we can remove
So-
it. 'Cause
And then the parachutes are protected by a Kevlar Nomex
Okay.
deployment bag as well, and it's black powder charge ejection for both drogue and main.
Okay. Okay, and yeah, we'll discuss the ejection here later on. Okay, so I see you've got it basically bolted into the top bulkhead, the aluminum bulkhead with your charge wells. Okay. And did you sew the ends of that shock cord where it's hooked into your swivel link, or is it just knotted, or what?
We have a double knot here, so that's our swivel here.
Is it figure eight?
Okay.
Yep.
And then that's all.
And then a stoppage knot as well. We thought that would be more secure than sewing anything, considering it's a circular cord as opposed to like a flat 1/2 inch nyloner, which we used previously. But this was lighter weight with the same survivability. Although obviously it's less elastic, but that's where the extra length comes in to sort of attenuate some of that load during
Kevlar
Okay.
doesn't give. Why?
Yeah.
Just curious. Why did you tie that extra knot versus just taping that in?
just additional security. We'd rather be overcautious than anything else.
Yeah. One of the things that you got to be careful with is that, when you tie a knot into something, then that actually increases the weakness
Yeah.
of that cord. So the kind of knot you've got, it has a big deal on exactly how strong that cord is going to be
Yeah.
before it comes apart on you.
Yeah, so that's something that we consider that this should be about 80%, 80% effective, as in effective load bearing of 80% at the knots.
Okay.
And the cord is rated for 1.8 tons, so metric tons.
Yeah.
I mean.
Yeah. Should be plenty. How are you arranging your shock cord in there? You know, when you fold the when you know fold the parachute, fold and pack
Yeah.
everything. How are you fixing your shock cord so it's going to come out in a nice orderly fashion?
So we've previously used masking tape before packing it
Okay.
in, which should again keep everything nice and ordered while it's in there and prevent anything from tangling or knotting as it all comes out. And then obviously it'll rip out quite easily as it unfolds.
Right. Yeah, it kind
Are
of
you
helps
using?
cushion things a little bit too, you know,
Yeah,
because Kevlar's got no stretch to it
yeah,
like
yeah, yeah.
nylon does. Okay. Oh, sorry, Chris.
Are you going to Z fold it, or like what? I want to know like how you're when he asked
Uh,
the arrangement. You want the
yeah.
details.
Sorry. Yeah, it's a Z fold on the cords as well as the gores of the parachute as well when it's packed.
And how much cord above the bag versus below the bag when the is
It's
tacked up?
the mid. It's 1/3 along.
Okay. Are you doing anything to see where that shock cord is laying against the edge of your tube there?
Yes. So we will be using a 20 millimeter foam that's currently on order and on the way as well, which will be secured at the point of contact, just to stop zippering, which is a problem we've had in previous ejections.
Oh, so you have seen that. Okay.
Yeah. We've had zippering occur previously, so we were trying to be quite cautious, especially with the cord being 8 millimeter. When we previously used 1/2 inch tubular nylon, which obviously has an increased surface area, so we do want to try to minimize the risk of any damage to the airframe.
Okay. Well, but you also risk, depending on the airframe, you risk damaging the cord too. That can be a
Yeah,
pretty abrasive surface.
yeah,
So, worst case, you put a pretty good wad of duct tape right there where it hits.
yeah. As I said, we were considering using EPDM tubing, so just kind of rubber tubing to increase the surface and also give it a little bit of flexibility and padding on contact, and just securing that in place with some duct tape and another knot potentially.
And you said you put one wrap fiberglass on this?
Sorry, we put 1 mil of fiber.
1 millimeter of fiberglass.
So 5 wraps on it over 2 mil acrylic.
5 wraps, 1 mil. Okay.
Yeah.
Yeah.
Thank you.
Yeah, because we've done a second separation point.
Yeah. Just click.
Don't get it. See, that's a problem.
Yeah, that's probably easy to get the avionics bit out as well.
So, do you want to bring other stand over as well? Or that? Yes. All right.
Sorry. Yeah.
So this was actually a point that we were quite interested in to hear from you guys. So this is tubing that should have 127 mil external diameter, but there's a bit of wobble in between the two airframes, and we're actually looking for your guys' opinion on how we can improve the fit and finish of the coupler.
Is that aluminum?
It's aluminium, yeah.
All right. Have you do you have a lip on that that plate that goes into it
We
to
don't.
keep it centered?
We don't. Usually, we just torque it up. So we don't have those tools right now, but we usually put torque on it, and that's what I've done
All right.
as well.
Is that the same way at the other end?
On this side, sorry, here of the coupler.
Yeah.
There's not a bulkhead on this. Well, we've got our forward closure up there and our payload support.
Yeah.
Okay.
And you've got it on that side, you know, toward the aft. You've got it basically bolted in, right?
Yes, it'll be bolted in. That's our job for this week. We're going to be putting holes around the coupler. I think we're doing 8M4s, tapping it and then threading it through. Yeah.
So
As well as these
one of
rods. Sorry, these rods also run to the forward closure. So they run all the way down here. So we have retention kind of in the vertical direction, and some retention and shear, but the most of the retention is coming vertically because we don't want to wreck the airframe if possible.
All right. So I worry a little bit about a free floating disc on top of there because
Mhm.
when you put a lip on them and you index them, then you can kind of get a consistent fit.
Yeah.
Right. There's the possibility of that being off center a little bit, and then it's tight when it goes together, and then it doesn't come apart when you want it to.
Okay. Yeah.
You understand what I'm saying, right?
Yeah, I understand what you mean. Do we have an easy way to put a lip on it?
We could probably get a technician to machine it.
We can maybe get some today. Yeah. We can maybe get them on lathe, yeah. I don't know how much grip they've got on. Yeah, we'll certainly look into putting a lip on or machining one. Or do you guys have any other way aside from machining it that you can think of?
The only other thing you could do is get a piece of fiberglass or wood to put up there at the top and have it be your index point, but it's a little less solid than a lip fixed to the aluminum.
Yeah.
Doesn't need to be a big lip.
What was that, sorry? Maybe you could say
It doesn't need to be a very big lip, right? Just hold it in place.
You can fail it on the side.
fail it on.
So it's like going at a bit of an angle, kind of.
Maybe. Yeah, we'll definitely look into getting a lip
All
on
right,
it.
yeah. I don't think we need an answer right now. Just think
Yeah.
about that before you show up.
You'd have to.
Okay.
Yeah.
Cool.
How are you gonna, what bolt, you said you're gonna put 8 screws in to hold that in? Are you gonna just do like one ring of 8? Or are you gonna do 2 staggered rings of 4? Or how are you thought about how you're gonna do that?
The current plan was just 8, because it's a secondary method of retention as well, because the first one does come from these rods, because they run all the way through into the forward closure, so it's being pulled up from the motor at the bottom. Our plan was just 8 and 1, but 4 and 4 is equally viable, and we can definitely do.
I don't have strong, opinions either way. I know some people like the staggered pattern, but
Yeah.
it just.
Yeah, we can definitely do staggered ones then. It makes no difference to
Your trade-off there is how much meat between the edge of the whichever tube and your hole, right? If you do a single row of 8, you can kind of split the difference and you get the maximum distance between the edges.
Mhm.
If you do the 2 rows, then you get closer to one edge or the other.
Yeah.
Right?
Yeah.
So
yeah.
I don't think we're
This
trying to
question-
tell you to do one way.
What was that? Sorry.
Yeah, what we're not trying to tell you to do it one way or the other. It's
Okay.
it's just a trade-off. It's your decision. I'm just curious what you were thinking.
Okay. Yeah.
Yeah. So at the moment we're going for one ring of 8, and if you're both happy with that, I think we'll sort of, for the moment at least, unless you've got any sort of other ideas, we'll just go ahead with that.
I think that's fine, especially you're saying those rods that I see protruding from your forward, that top plate, they go into the motor. Is that?
They go into the forward closure, and the forward closure is attached to the motor. So it's retained vertically on the rocket instead of in shear.
I mean, I think what I'm looking for is you've got good, we'll call it adhesion, right? You've got good connection from that harness through your motor.
Yes. Yeah.
Right. The tube is then just bolted on there so it doesn't rotate.
Mm-hmm. Yeah.
Oh, that looks good. Yeah.
Cool. I guess gonna move down to our rail buttons, fins, and boat tail then.
Yeah, going further down. Use economics. So
yeah,
you sort of see them down here. We've got 4 fins here made from a carbon fiber layup. It's 20 layers of 0.90 and plus minus 45, and they're sort of swept slightly and they've got a bit of a taper sort of sanded on the leading and trailing edges to improve the aerodynamic performance, which was done by our mentor Ben Jarvis. Then got 7 layers of tip to tip on them, sort of of varying thickness to try and give a sort of taper from the root to the tip to sort of help prevent flutter by having a slightly varying thickness along the sort of span of the fin. But they've been rated, the fin flutter calculations have been done, and they're well above safety factor 2.4 above flutter velocity.
All right. Have like a printout or something like that ready when you go to your inspection there on site. Is that something that you should have handy? You know, just a 1-page, here's our calculations, here's how we did it, so that you can show the inspector.
Great, yeah, we'll get one of them made up. Thank you.
And what motor are you flying?
It's the O5500.
What?
The O5500, the
Oh,
Aerotech.
5500. Is that a disposable motor, or is it a
Yes.
perfect?
Yeah, I mean, we're picking that up, got off Wildman, and then we've got the Aerotech assembly thing on. It's either Monday or Tuesday, and then we wait 24 hours for all the for it to cure, and then we can fly it. That's the current plan, at least. Yeah, so
Okay. I haven't glued one of those together yet. I've seen others do it.
Mhm.
I do a lot of SRAD motors, so we bond the grains ourselves.
Okay, cool. Yeah, there's a YouTube video as well that we're gonna get everyone to watch, and then
Perfect.
yeah. Yeah. You guys have any more questions on the fins, or should we move to the boat tail and the motor retention?
Were they surface mounted, or are they
Through all mount.
through? Okay.
And then seven layers of lay up varying thickness. So there's different damping ratios throughout the span. So we're quite, we think both will survive calculations really well for that. So
Okay, so tell us about your boat tail here.
yeah, sure. So the boat tail's tapered. It's made from aluminium. It's got a 9 degrees angle. We ran a couple of simulations based off the mass of it. It comes apart in two. So this bit here, it screws off. What this does is it acts as a secondary form of motor retention. So if Tom shows the inside there, you can see that we've got a thrust lip here. Then we have a bit of material and then a tapered angle down there that transfers the force straight to the airframe. So we're and then after that we pop this bit back on. We've got all the dimensions from Aerotech drawings. So this bit will stop the motor falling out the aft of the rocket as well. And then we have our second method of motor retention up at the forward closure of the bolt, the standard bolt that we get.
Okay. And how do you have your rail buttons attached?
So we got them. Where was it? Was it Apogee Components we got them off of?
I believe so. It's the 1515 one.
Yeah, 1515. So it comes with an what's the name of the nut? But it's the one that you can mount through the wall. So there's a nut on the back of here that also comes partially through the airframe. In fact, do you have a screwdriver, Logan?
Got that weld nut behind it, the flat.
Is that what? Yeah.
I
Now
think
what you're talking about, a weld nut?
I think so. Yeah. Sure. So I'll just unscrew it just to make it a bit.
Looks like a little T.
It's not got teeth on it. This one.
No, it looks like a T, isn't it?
Oh, T.
Like,
Sorry. Yeah, you're right. Yeah.
It looks basically like that. Yeah.
Oh yeah.
Okay.
Yeah.
So we've got two of them, one there and one there. Just two, because three, you're risking it not being aligned.
Did you glue it in? Would you?
Yep, it's all epoxy done.
All right. Y'all know not to over tighten those, right?
Yeah, too much I might break it off. So we'll keep it cool.
Well, not break it off. You squish. I had a different team in a different competition over tighten their rail buttons, and they squished them, then they won't slide on the rest.
You squished. Okay.
Oh, okay.
Yeah. Okay.
Yeah.
We'll definitely be cautious about that then.
Yeah. So snug, but
that
not too
happened.
tight.
Yeah, that happened to a couple teams last cup where they over tightened them, and then basically, fortunately, we're able to simply take some tension off and and unsquish the rail buttons. But yeah, you don't want
Okay.
Yeah.
I think we've got spare ones as well, so that we'll bring them now just in case we manage to squish it. But yeah, sorry, I
Yeah.
don't know about that. Yeah.
Okay. And just the I know we haven't gotten to your avionics bay yet, but so and you've thought through exactly how you've got your avionics bay oriented, so you're not um, so that the parts you need to reach aren't going to be right up against the rail when the rocket's on the rail.
Yeah, we've got we've got diagrams for arm mounts, so we don't stick them on there. Oh, yeah, so we don't stick them on the rail.
Yeah, because that's happened more than once. So,
Yeah.
Yeah.
We could move up to avionics bay if we're
okay.
ever that stuff down here.
Let's see that.
All right, do you want that one?
So what we've got here is the avionics bay. It's just a COTS coupler from Wildman, and you can see the sort of standard smaller charge wells for the main deployment. But because the drogue's a high altitude deployment, we've got a slightly different set of deployment charges here that will like our recovery lead will quickly talk you through.
60mm line. So we've got a document from Jim Jarvis we found online, as well as a couple of other sources. Obviously saying black powder deployment might be less effective at higher altitudes, so we wanted to maximise the volume of the charge wells, basically to ensure complete combustion and proper pressurization of the drogue parachute bay.
Okay. And so then you basically got something to seal the tops of those charge wells, at least to hold the pressure in there long enough for the black powder to fully combust and then pressurize the bay.
Yeah, absolutely. So what we've done previously is made a kind of rupture seal out of just electrical tape. To ensure a better seal, we've actually got the E-matches going through the bulkhead there.
Yep.
On the main deployment, the E-matches all going through the top. As that's what we've done previously, and that's had good success. But we just wanted to be quite cautious with the drogue deployment at high altitude, ensuring a proper seal. So we've just got them coming in through a nylon bolt, which will be epoxied, to ensure everything is sealed and there's no blowback into the avionics bay.
Okay, good. What's your on your quick links? What's the rated strength on your quick links?
So the lowest rated component has a maximum braking strength of 1.5 tons, which is the swivel links.
Okay.
And so we're expecting a maximum deployment force of about 600 kilograms. That's main opening from drogue speeds. So we're reducing speeds from about 25 meters per second under drogue to 6 meters per second under main, and that's our highest loading.
That presumes what attitude, what angle of attack, like at apogee? Because the rocket doesn't go straight up and tail, right?
Yeah. So can you repeat the question? Sorry.
So typically the rocket goes up,
Yep.
and it's not going to go straight up and then tail stall and then fire your ejection charge, right? The rocket is almost guaranteed to have some forward motion, right? Some angle of attack that it's kind of flying horizontally, so to speak. What was the maximum speed you considered of your horizontal directional speed?
For drogue deployment, sorry. Or for main
for the
deployment?
drogue. For the drogue.
About 20 meters per second. About 2 seconds after deployment. After apogee, sorry. Which is more than what we expect anyway.
Okay. So the eye bolt there,
Yep.
how are you going to keep it from rotating? What's the plan?
So there's a secondary eye bolt, as you can see here, and they will be connected as well with a quick link.
There'll be one on the other bulkhead as well.
which will obviously take any of the
Yeah, they're last year we did a simple thing where we sort of connected them like that, then wrapped it in electrical tape because these
to stop any conduction.
these wee isolators here just sort of stop any sort of shorting out. So if this is covered in electrical tape, it's not going to short the circuit that the EMATs need to deploy.
Okay. Are you going to do that same thing on the other end?
Yes. Yeah, we'll do it both ways.
And then on the nose cone, and here we've got a U-bolt to prevent that from happening altogether.
So on the aft, you've got that U-bolt, and on the nose cone, you say you're going to have a U-bolt as well?
Yes.
Okay. The eBay, the ends on the eBay, are they stepped or are they free floating too?
They're free floating as well.
Okay.
That's going
That just has to slide into your tube, right? That you're going to bolt that in, or how does that stay fixed in the tube?
correct. Yes, so we've got a retaining ring. So it's like a center except we have it's the same idea with a coupler with 8M4. That's getting made this week. We attach that to the bulkhead and then we bolt it in so it won't come free. Yeah, it also stops any spinning of the bay.
That'll center
Where,
one of the bulkheads as well at the same time.
Yeah.
Inside the coupler tube.
Yeah, so yeah.
so the bolts go into the coupler tube? Is that what I'm hearing?
The coupler and the upper airframe and the ring.
The ring will sort of
Okay.
sit about here-ish, and then the sort of holes will go through the airframe into the coupler, and the retaining ring here will stop it moving laterally or rotationally.
Okay. Oh, is that smaller diameter than your tube? Is that what I'm understanding?
Yes, it sits inside.
So the retaining ring will sit inside this coupler tube here, so it'll be sort of slit the
Okay.
its
Okay.
external diameter will be the internal diameter of this.
Gotcha.
Okay. Okay. So you take your bay loose so we can see the how you got your electronics.
Just these the
I didn't use the other one on that.
Yeah.
So the electronics are mounted on 4 shelves throughout the bay. We have the main flight computers, the primary tracker, the ESRA flight computer.
Maybe best to put it on my bird.
All right.
It's like that over there.
They are each on an individual board of plywood, 5mm thick plywood in here, which are screwed onto this central 3D printed mounting column. Effectively, when these screws are taken out, you can take each board off individually, and it's like a self-contained version of the system. The batteries and power for it will be on the opposite faces of each board, and just lets us work on it individually at a time. Then when it flies, obviously put these boards in, screw them onto the mounting column, which is screwed itself onto bulkheads on either side, and a threaded rod through the middle for compression. The tracker itself, we have as primary the Easy Mini V3. We've used that in the past. It has been reliable for us in the past. We used it in all previous spaceport flights we did last year and the year before that. And as well, we have a COTS RRC3 Missile Works primary flight computer, just as a backup redundancy to that system. For primary tracker, we have the Altispectrum Tele GPS and TeleBT tracker. This is held here, and it's on the 433 megahertz band, programmable within that band for low bandwidth, so there shouldn't be any interference issues with it. And we obviously have a SRAD flight computer over here. Currently, we did some test flights, and it hasn't been fully successful yet. The flight computer was performing as expected, but on the way up, the battery holders we were using broke and we lost power, so we can't say that was the correct flight. So in the event that we don't get this flight tested before the competition, we will have it here as data logging, but we won't connect it to anything. And we'll instead use the two COTS components as primary and redundant flight computer.
So do you
Okay,
have
so-
the RRC3, the little programmer LCD screen?
We do not have the LCD screen, but we do have a application on the laptop that will let us see what's going on with it.
Okay.
The default
So-
settings should be enough for the RRC3. We shouldn't need to do extra programming. It would just be for data extraction.
So talk to me about your apogee ejection charge stagger.
So as the primary flight computer will deploy the ejection charge at apogee, the secondary is set to deploy 2 seconds after apogee is detected. So there shouldn't be a simultaneous explosion from both primary
So
and secondary charges.
which one of the flight computers is which though?
The Easy Mini is primary and the RRC3 is secondary.
All right. So the default settings, you're gonna have to change at least one of the default settings, right?
Yes, I've changed the default setting on the RRC3 already. It is set as 2 seconds after apogee.
Gotcha. All right. Now I ask about that programming LCD thing only because it's very convenient to not
Yeah.
have to drag a computer out. Yeah. Okay. And then who's got the ham license?
I have the ham license, full UK license, so it is acceptable in the US as well.
Yep.
Okay. How do you get your batteries mounted here?
We are 3D printing our own battery holders because commercial battery holders are not reliable in the slightest. We found out they should be good enough to withstand forces. We are either going to screw the battery holders in through the plywood, in the case where there's enough room on the back of a board, or epoxy them onto the back of a board. If there's no room for screws to fit through, then we will just run the wires through the board's back and into the power connection on each component that needs it.
And what kind of batteries are you using?
We are using 3.7 volt lithium ion batteries, compliance with the rules of competition, cylindrical form factor, metallic casing. They have 3,000 milliamp hours of charge, and they should last up to 12 hours for any component connected to them. As a sort of minimum, we have tested all of that.
Okay, yeah, because that's one of the things that they're going to really look at hard at your when you get checked at the convention center in Midland, is how well your batteries are tied into there. So that's one place you want to go belt and suspenders as it were, be very make sure that those batteries are not going to go anywhere, because especially with 3D printed components, we've seen a lot of cases where that component has failed under the vibration, and then if that 3D box or whatever is the only thing holding that battery in, then that battery is just going to be floating around in there, and that's not a good answer. So whether you zip ties or whatever to make sure that those batteries stay in there, then that's what you're going to need to be doing.
In previous years, we've used zip ties to hold the batteries in place as well, just sort of drilling wee holes in it, the board to sort of wrap it round. So we'll be doing that again this year.
Yeah. Okay.
What about your switches? How are you turning these things on and off?
Mechanical arming screw switches, which will be mounted on the edge of each bulkhead and screwed effectively to turn them on and off.
And they won't line up with the rail either. Better on that.
Okay, good. And, just again, reiterating my comment about making sure that you're where you have to access those screw switches is definitely on the opposite side from where your rail buttons are.
Yeah.
Yeah. Okay. All right. So tell us about your parachutes, please. Yeah.
So the Drogue is a Rocketman 4-foot experimental with a CD of 0.97. And the main is a toroidal annular 10-foot parachute with a CD of 2.2.
Okay. And your rate of descent under Drogue?
Under Drogue will be 6.3 meters per second, and under main will be 25.1 meters per second.
That's the other way around.
Yeah. The other way
Yeah,
around.
yeah,
I hope.
sorry. Drogue will be 25.1 meters per second, and main will be 6.3 meters per second, which is it's similar. We've flown both of these parachutes before on a slightly larger rocket, and the calculations are kind of in line with our previous experimental data as well.
Okay. Okay. Let's see. Down to. Chris, you got any other questions or things you want to point out or check with?
I don't think I have any other questions really. I mean, it
Okay.
looks relatively okay.
Yeah, yeah. Simple and straightforward. Especially for your first 30K flight. That's where you want to be. Okay. Tell me about your. It's not strictly part of the review, but tell me about your payload.
Well, we don't have our payload.
We do.
It's heaped over the leads and it's out.
So
So both people who we have sort of in charge of the payload this year are not here with us right now. Effectively, the payload is a measurement of flight parameters within the rocket. It will be doing 3 primary measurements at the time. It will be recording the temperature within the payload bay, and we're also recording temperature within the avionics bay, so that'll be a nice way to sort of tell the difference in temperature along the airframe between sort of central coupling point and within the upper airframe. It's also measuring the spin rate during parachute deployment and descent, and vibrational analysis using a strain gauge mounted within the payload support structure, which will effectively be able to tell us what sort of vibrations are happening in the aircraft and any way that we could potentially reduce that in future years. And spin rate's the same sort of idea.
Okay. And so that little board that you're using for your measurements, and that's going to be how are you going to mount that within your payload structure?
Mounting within the structure, I believe it just goes on one of these shelves here.
Okay, so it's just going to sit orthogonal to the direction of thrust.
Yes.
Okay. And what kind of battery do you got in there?
Again, 3.7 volt lithium ion, 3000 milliamp hours.
Okay, and you're just gonna mount that on the bulkhead?
Yeah.
Kind of like
yes. Okay. Within one of these shelves, probably.
Are you guys using the same battery for everything?
Yes. Well, no, sorry.
The same type of
battery.
Same type of battery, yeah. Not a single battery for all. But
this payload's independently armed with an army screw here, a battery over there, and it's mounted in this coupler here. Whereas the avionics bay is up in the upper airframe, and it's got a couple of batteries powering the computers.
I'm asking, you're using interchangeable, like the batteries are all interchangeable with all the things.
Yes.
Man.
And they're also chargeable as well. So
that might be the first time I've seen that on a team. That's a good plan.
Yeah, very good plan. And most teams don't think that through, and they got, 3 different kinds of batteries to keep track of.
Yeah, we're going to one type of charger and one battery. It'll be great.
One
It's
charge,
much
yeah,
easier.
exactly. They got 3 different kinds of batteries. They got 3 different chargers. They don't have all the right cables for the thing. Like it's almost comical to watch. Unfortunately, they're pretty stressed when something goes wrong. But yeah, and so I presume then you may be bringing spare batteries.
Yes, there will be, I think, 2
Wow.
spare batteries we currently have.
Okay. And I know you said it, and I just kind of spaced it. Where exactly are you mounting your payload?
It's in this coupler here.
Oh, in that coupler. Okay, gotcha.
Yeah, so there's sort of a 3D printed support structure, which is the same as the external diameter the internal diameter of the coupler, which is going to sort of hold it in place. That's 3D printed out of PETG, so it should withstand the desert temperatures. Yeah, there's another part that's going to sort of sit on top.
Okay. Okay. Well, that looks good. All right. So, let me just go over some admin things here. Where are you all planning on staying? Have you already got your rooms at the competition?
Yeah, we've got an Airbnb booked
In Midland.
out in Midland.
Yeah, so an Airbnb for us all in Midland.
Okay. And you know that it's going to be about a 2.5 hour drive each way to the launch site to Midland there.
Yeah, it'll be an early morning for us.
Yeah. Yeah, that's unfortunately I'm not going to be able to attend the competition because I got to have open heart surgery between now and then. And but I'd actually booked a room in Pecos, so it was not going to be quite as far for launch mornings. But yeah, y'all are young, so you can do that kind of stuff.
Yeah, we stayed
Okay.
in Christmas last year, so we're used to the sort of early starts.
Yeah, yeah. And you've got your visas and everything like that's all squared away.
Yeah, all got arrested, so signed up on that. All been approved.
Up Tripoli as well.
How many people are you bringing?
7.
7 of us will be going. All Tripoli members all got arrested, so that's all been sorted.
Was it 7?
Yes, 7.
7 total members? Okay. Is everybody a Tripoli member? Everybody's going to do recovery? What's the plan there?
Everyone's a Tripoli member. We've allocated a recovery team of 4 members as well.
Okay.
And some of us have been there before, so we know what to expect in terms of conditions for the recovery team.
Outstanding.
Yeah. Yeah. The difference between Midland and Cruces in terms of the heat and the wind and everything else, it's you're basically looking at the same deal. The issue, and because that area that you're in is basically you're basically in the oil field, so it's pretty flat. There's not, you don't have the same types of vegetation to deal with, but still, you're going to want to dress for it. Long pants, good shoes, no flip flops or anything like that. And unfortunately, black is not a great color to wear out there. So especially for the fair skinned among us, when I'm out there, you'd see me with the long sleeves, a big hat, everything else. You just want to cover up and keep your skin out of the direct sun as much as possible because you do not want to be get sunburned on the first day and then have to go through the rest of the competition that way. That will be a long, miserable week. Let's see. How about your motor? Have you obtained your motor yet?
You said Wildman's coming with it, right?
Yeah, we purchased it off Wildman a couple of months ago, and we're going to pick it up at the competition.
Okay.
How are you getting your rocket there?
That'll be in the checked luggage of 2 members of the team. We've gotten it to competition that way previously because shipping it sort of independently, we can't really rely on it. But if it's on the sort of same plane as us the whole way, we know that we'll get there with it.
Okay. You can get the fin can in some sort of container, or how do you do that?
Yeah, so we designed it initially with the oversized luggage restrictions of British Airways and American Airlines in mind, so that the sort of big boxes that we'll be putting it in are still acceptable for the flight.
Okay.
Okay.
One of the other things you need to know about Midland, Bill already mentioned it is an oil field town or whatever. The roads there, I live in Texas. I don't live that far away. It's a few hours for me, but I go there frequently. I have other rocket friends there, and that town is perpetually overrun with trucks, lorries, right? Big lorries, like with massive loads on them. The roads are kind of terrible and usually under construction. So be extra vigilant when you're on the road. You're already going to be driving on the wrong side, right?
The wrong side. Yeah. There's a European member on the team as well that's driven on the wrong side of the road. Well,
yeah,
wrong, right?
Yeah. Well, anyway, so just be extra vigilant with
Yeah.
the traffic and the big trucks.
of course, yeah.
Right. And I saw you're renting a pickup truck as part of your vehicles there.
Yeah, back up in
Yeah,
7-seater. So
Okay. Well, that'll certainly help you too. Okay. I think
When
we've
do
covered
you
everything.
arrive? What is your arrival
Yeah.
and departure dates?
We arrive late night on Friday, the 6th of June, which gives a few days to sort of get settled, get into the time zone, and sort of set up the rocket ready for the first day of the convention centre. And we leave on Tuesday, the 17th, so a couple of days after the competition ends.
Okay.
Okay, good. Okay, and you know that the competition will be providing tents and tables, so it'll be kind of like last year with the big tents and everything. And so you just need to make sure you either bring or are prepared to buy your own chairs once you get there.
Yeah, we've picked them up for sort of cheap ones from Walmart before, and they've served as well, so we'll be doing that again.
Yeah. Yeah, it's probably a better plan than trying to slap them on board your airplane there. And plenty of places to buy stuff around there, so that shouldn't be an
It's going to
issue.
cost you more to ship them than just buy new ones and throw
Yeah,
them.
exactly. Exactly. Yeah, we could, we could we could set up a business, Chris. We could buy a whole bunch of, super cheap chairs and, just bring them all
Dollar,
out to the competition
yeah,
and,
$1 a day rental or
at
something.
a slight markup.
Yeah.
All right. Well, it all looks good, team. I think, you got a couple minor things to finish up on and, to think about, how you're going to, make sure that first coupler is nice and stable since it's, since you got that size difference, so, do the little lip or whatever you need to do to make sure that that is, because that's one of the points that the safety inspectors are gonna press you on as well. If if you got any kind of movement or flex in there, then that's not a good thing.
So you're using phenolic or something similar in as one of the tubes, yes?
Our airframes are phenolic internally, and then sort of the layer of fiberglass, the fat mill of
Okay.
fiberglass on top of it.
So you've got dissimilar materials there, and I I would suggest you come up with some sort of plan to make that a better joint. But I don't know what color you're going to paint your rocket, but I would honestly take the rocket when you get there and put it out in the front yard or the backyard or something like that in the sun, and then check the fit after it's been in the heat.
Right, our rocket, we're planning on painting it white, but we'll sort of test the sort of fit. Whereas you said in an email previously that you used some tips on sort of avoiding any sort of wobble.
Yeah, blue tape or something like that would potentially stabilize it. I mean, if it's a really big gap, you can do something like coat the inside of that phenolic with a little bit of glue and then sand it to fit.
Yeah, we're thinking of either laminating resin or some type of epoxy to get it up.
Yeah, you can do that, a couple layers of epoxy and then sand it back to fit. But I'm just saying on Saturday that, right after you get there, put that thing out in the sun, heat soak it, and then try the fit and make sure that it doesn't change significantly, right? Moisture and temperature, especially when you've got phenolic, is bad about absorbing water, or what people complain about that in blue tube.
Yeah.
If they get wet, their dimensions change slightly. And then aluminum and the dissimilar materials is I don't want to say it's concerning, just you need to be very cognizant of that.
Yeah, we'll be aware of that, and we'll sort of test it. We've got a few days in America, sort of deliberately to iron out these sorts of wrinkles and make sure that everything's ready by the time we come round to launching.
Okay, that sounds good. I'll go ahead and mark you off for the flight readiness review. The one thing I did notice is that you're on your form that you're still showing Ben Jarvis as your fire record instead of Chris. So you need to make sure you correct that for your for future purposes. But otherwise, that's just minor admin stuff, so I'm not too worried about that.
Is that just a case of emailing the ESRA email to update it?
I think so.
Yeah.
I think
Yeah.
so.
Right.
Well, and then
They
when
can
you
fix all
register
that.
your team, right? There's a team registration you have to do or whatever. I don't know if y'all did
Yep.
that.
We got a registration thing from Da Vinci a few days ago as well, which says we need our flyer of record. So I'll email that over to you after this.
Yeah. Yeah. Okay.
Okay.
Do you have any questions for us?
I think aside from the coupler.
No, I think there are sort of one thing was in the coupler, but you've given us some things to think about there. Everyone else quite happy. You've got no more questions or queries for us, do you?
No, I'm good. Yeah, but anything related to, I know we've talked about local conditions, anything competition related that you've got questions or just want a little more information on, now's the time to ask.
No, I think there's a few of us been to competition before, so we've got an idea of how it works. I don't think there's anything particularly we're worried about here, are we?
Nothing pressing. As much of it's just we'll find out when we get there, gauger systems and stuff like that.
Yeah, there's a couple of systems updated, but similar to last year, sort of with registration
Right.
and the safety reviews. But I think that'll sort of be explained when we get there. I think that's Sierra's working on a lot of that.
Yeah, and I think one thing that you'll find is that that Midland has really embraced this event. They've given us a degree of support and just a lot of physical, tangible things. So I think you're actually, even though I live by Las Cruces, so I'm kind of kind of a homer on that. But the facilities in Midland, the convention center is better. It's bigger. I think the launch area, they've really done a lot. Grading roads for us and things like that to help help us get all set up. So I think we're gonna have y'all gonna have a good experience there. Midland's a lot uglier town than Cruces, but it is what it is. It's we got to find the big open spaces for these rockets, and we won't have quite the same kinds of restrictions as far as being able to go out and recover and do stuff that we did at the spaceport. So I think that operation is going to work out a lot smoother. Um, so I think it's going to be a positive change for us. And Midland's a good town, lots to do. But like you said, it's you're in the oil patch. You're going to smell it. There you go. But that's what you got. All right. Any last words, anybody?
No, just that's great.
Okay.
We're gonna finish recording and send that over.
Yeah. Make sure you send in the link to the video recording, and